Okay, one of the goals of earth science is to understand what the earth's surface looks like and why it looks that way. So we're going to look at the surface of the ocean floor, which we've already started doing. We're going to look at the earth's surface, mountains, valleys, etc. And we are going to try to explain why the earth's surface looks like it does in certain places. Now, to do that, we have to take a look inside the earth and understand what's happening there. So one of the processes that happens inside the earth is called convection. Now, I'm going to use this example of a campfire to show you convection in the air. Then in a few minutes, I'm going to take that and we're going to try and apply it to what's happening down underneath the earth's surface. So for starters, let's go camping. Here I've got a terrible picture of a campfire. Wood, flames. As a result of this, what's the air like right here? It's warm. Now, when you have air that's warm, that warm air is less dense than the air around it. That means the molecules are going to be spread out more, okay, than they are elsewhere. Now, less dense air, which you hopefully learned in physical science, is going to rise, which is why we often say warm air rises. Now, as it rises, it starts to cool off and become more dense. But this air rising pushes it out of the way, and what happens is you start to get a pattern, and eventually this air is going to get cool enough that it's going to become more dense, and so now it's going to start to sink. And as this air rises, it pulls in air from the sides, heats it up, and makes it rise. And so what you end up with then are called convection currents, where the warm, less dense air rises and the cool, more dense air sinks. Now, this happens anytime you have heating taking place in a fluid. So this is in a liquid or a gas. Now, some kids have this misconception that underneath us, underneath the ground, is a bunch of air. That is not the case. Earth is not a big balloon. It's not blown up like a balloon. It's rock. Now, some of the rock is molten, which means it's melted, but it's definitely not air. So we're going to take this example that takes place in the air, and we're going to show how it takes place in a fluid. So it's going to take some quick artistic skills here. So here we have the earth. Okay, and we're going to call this the crust. So the crust of the earth is a really, really thin layer. It is all the way up here. That is the crust. Now, underneath the crust is a really thick layer. This layer is called I need a different color. Let's go purple. The mantle. Now, the mantle is very, very large. Okay, so I'm going to write right in it. Mantle. So this is the mantle. Now, inside the mantle is an outer core. Outer core and an inner core. For now, we're not going to worry so much about those. We're just going to know that they exist. What I'm more worried about is this. The crust is totally solid. In fact, it's solid enough that guess what? Oh, come on, pen. You can do it. You can do it. Oh, I'm going to try a different pen. Try again. Here you are. You are standing on the surface of the crust. Now, if you go down to the mantle, it's going to start to get warmer and warmer and warmer. In fact, you're going to get down about to right here, which you can't possibly go this deep, but imagine you could. So notice we're still in the mantle here, but we're still in the upper part of the mantle. You hit this point and all of a sudden, this weird thing happens, and that is it becomes partly molten. It becomes movable. So let me just say it a different way. The mantle is solid rock, except for this very small area in the middle of the mantle, upper mantle, somewhere in there, where it's kind of fluid. Now, I say kind of fluid because we don't have good words in the English language to describe this. When things are solid, they're solid, right? When they're liquid, they're liquid. What happens when they're right on that line between solid and liquid? So it's kind of mushy, it's kind of slushy. So basically the deal is it's a solid, but it can flow really slowly. And so what we find is we have these circular convection currents happening. And sometimes they're really small, like the ones I just drew, and sometimes they are really wide, like the ones I just drew. So these convection currents have certain areas where it is warmer and it's rising, and cooler and it's sinking, and then warmer and it's rising, and cooler and it's sinking. Now, the only reason that matters is this top layer up here, so I'll say from here to there. This is all solid, right? So the crust and the top part of the mantle together have a name. That's called the lithosphere. This area down here, I'm just going to circle it real big, that's moving has a name. That's called the asthenosphere. All right, so the lithosphere is what we refer to as the plates that make up Earth's surface. Now, when we say plates are moving or there's plate tectonics, it's a lithospheric plate. Why are they moving? Because in the asthenosphere, the middle part of the mantle, there's convection going on because there's areas where it's less dense and more dense. As a result of this moving, it makes this plate move that way. Since this is moving, it makes this plate move that way. Let's just imagine that this plate is doing this, or I'm sorry, this current is doing this. That means I have a plate that's this big that's moving the same way. Now I want you to notice something. If I have two plates coming together, something crazy is going to happen here. If I have two plates pulling apart, something weird is going to happen here. The whole point is Earth's surface has some cool stuff going on. Mountains, valleys, trenches, mid-ocean ridges, and it all happens because of plate boundaries. Plate boundaries happen because deep underneath it, down in the asthenosphere, there's convection currents that make the plates move in the first place. Without that convection, plates wouldn't move. Without plates moving, you wouldn't have your mountains, you wouldn't have your trenches, you wouldn't have earthquakes, you wouldn't have your volcanoes. So anyway, it all comes back to this idea of convection down in the mantle, specifically in the asthenosphere. So on a side note real quick, when we talk about the inside of the Earth, structurally, lots of times we talk about the crust, mantle, outer core, inner core. When we talk about plates moving, we usually just talk about lithosphere and asthenosphere. It's just two different ways of looking at the same stuff. Okay? Technically, the lithosphere is the crust and the top of the mantle, and the asthenosphere is the upper middle part of the mantle. Hopefully that makes sense. If you got questions, shoot me an email. I'll be glad to help you out.